All right. We've been talking about how to analyze data. So we've gathered a bunch of data. I went around my trees, remember, from the last few videos on mean, median, and mode, and standard deviation. We went through and I measured a bunch of my trees, and I got a whole bunch of data points, and I was trying to answer questions about my trees. Okay, all that was good, but what I was doing in the midst of that is I was gathering a whole bunch of data, and I was trying to look at the data as an entire group. Okay, as an entire group. And we talked about when you plot out this data, you look at it, sometimes it can form this bell curve, right? And remember, we have a bell curve. I'll just draw my bell curve like this. There's my beautiful bell curve, isn't that great? Okay, and we talked about with a normal distribution curve, and that is not a good curve, but that's okay. In a normal distribution curve, that midline right there is both the mean, the median, and the mode. It all represents the same thing. And then we talked about we can calculate the standard deviation, and that would be about 34% coming this way and 34% coming this way. Give us about 68% of all of our data lies within that first standard deviation, if you remember that. And then we talked about the second standard deviation. And inside of that, we have about 95% of our data. And it continues to go on after that. So some things about reading graphs, a little bit more about reading graphs, is if you realize that if we have a normal distribution curve, a normal bell curve, that we have 50% of the data is going to lie on this lower part of the graph down here, where 50% of the data is going to lie on this upper part over here. Underneath that curve is 100% of the data. It's all of it right there, right? So why am I telling you that? Because another interesting thing that you can do with this data, we've looked at the broad range. We've looked at how all this data all works together. So we have a whole bunch of data about the trees, and we've looked at the mean, median, mode, we looked at standard deviations, we've calculated all of those things. And then the question, what if we actually have a question though about one particular tree and where that tree fits in the grand scheme of things? What if we have that question that we're trying to answer? Well, that is what the z-score will tell us. So I'm going to talk a little bit about the z-score. Here we go. The z-score is simply this. The z-score is a number that will tell us how many standard deviations a particular data point is from the mean. Okay, so if I have, I put my bell curve back up there, I'm gonna have to erase it again. Here's my bell curve, here's the mean, here's my first standard deviation, here's my second standard deviation. If I have a data point that's right there, that would be maybe 1.4 standard or 1.4 standard deviations. So we would have a z-score of 1.4. All right. If we have this side over here and we have a data point over here, that might be 2.3 standard deviations away. Okay. So in calculating the z-score, all we're looking at is we're looking at how to compare an individual data point to the rest of the data set. In other words, we've been looking at all of the data as a whole. Now let's take a magnifying glass out. Let's focus in on one piece of data and see how that data relates to everything else. So the formula for calculating the z-score is z is going to be equal to our data point minus the mean, remember that's bar x, over or divided by the standard deviation. So whatever the standard deviation is, right? If you remember from the data that we collected, our x bar, our average was the mean was 71.05 when it came to looking at my trees, okay? The standard deviation that we calculated was 35.28. That was our standard deviation for the data that we had, okay? So what I'm going to do is I'm going to analyze one of my trees. I'm going to pick tree number 118. I'm going to pick tree number 118. That was the, I'm going to call it 118. It was 118 centimeters. That was the number that I got. All right. And so if I run my formula, z equals x minus x bar over the standard deviation, that would be the same as z equals 118 minus 71.05 divided by 35.28. I've already done the math on this, and what the math shows me is that my z-score is a 1.3. A 1.3. What does that mean? That means if I look at my bell curve, all right, and I'm going to look at where tree number 118 would lie in the grand scheme of things, if here's my first standard deviation and here's my second standard deviation, then my tree would be somewhere about there. All right? What that means is if this is 50% of the data, over to that spot right there would actually be about 40% of the data. Okay? So if I add those two together, that tells me that tree 118 is actually, it's actually larger, or it's greater than or equal to 90% of the trees on my property. And that's what that number tells us. Now, how did I get that 40%? I'm glad you asked. Let me explain that 40%. That 40% came from a data table, which you can find online, or you can find it in your textbook on page 823 is where you can find it. So if I have a z-score of positive 1.3, if I go down on that data table, on that page, I will see that 1.3 is equal to 0.90 something, something, something. And if you round that and take the percentage, that gives me my 90 percentile range. And that's where I got that number from. So because that's 90%, I know that if the left of my bell curve was the 50%, then I know that to that point, it was 40% of the rest of the trees. So that's how we get the 90 from. That's what that number means. If you calculate your z-score out and your z-score comes out negative, that's perfectly fine. That simply means a negative z-score simply means that the individual piece of data that you're looking at will lie on the lower side of your bell curve. That's all that means. It lies on that side. And that's how you do the z-score. Z-score, again, allows you to focus in on an individual and how it relates to the whole bell curve. You guys are familiar with z-scores anytime you've taken tests like the PSAT or things like that, where it's given you your ranking, your national percentile ranking. Those rankings are all based on a bell curve of grades and scores that students from all over the nation have gotten, and where you lie based on, so if you're like the 95th percentile in mathematics, that's because you are a certain number of standard deviations. You would be literally 2 standard deviations to the right of the mean, and that is where they get that number from. So hopefully that all makes sense. I have a cat climbing a tree next to me. That was very exciting. And that's what the z-score is about.